If you have ever programmed in other languages like Python, Ruby, PHP, you'll be familiar with the concept of inheritance and object-oriented programming. Go is not an object-oriented language, as the creators has chosen to favor what is known as composition instead. A classical way of explaining object-oriented languages and inheritance is to think of a blueprint for, say a car. You have a base model that all other cars will inherit from. But doing it this way can and often will lead to some cars having attributes and methods that does not really belong on that specific car. What Go does instead is to define structs that would represent elements of a car, and when combined together becomes a car or represents a car. We don't really need to discuss the finer details of object-oriented versus composition. Both of them have their place. Just remember that in Go you need to visualize structures. But how do we create a structure? Well, let's begin by creating a user struct here. So we have the type keyword, then we have the name of the struct, and then we have the struct keyword. And let's say we are creating a bank and we need to represent a user in the bank this way. So we'll have an ID, that's an int64. Then we have a name, that's a string, and then finally we'll have the address of the user. And the way we can create a user from this struct is we go into our function here, say user, and it's a user struct. So the ID is just going to be 1. Let's say the name is going to be Alice, and then finally the address going to be 123 Main Street. Our users would also have an account in this bank, right? So to illustrate that, we could create another struct here. Let's just call it account that has an ID and let's just say a balance. And then we can go ahead and add this struct to our user struct. So now our users also has an account associated with them. An account will also typically hold transactions, right? So we can create another struct here. Let's say type transaction. And the transaction will again have an ID of int64. And let's say we have a field here called created at. That's a time, and then finally let's just say amount, again an int64, and then we could update our account struct to have all the transactions made on that account. So let's say transactions, which is a slice of transaction. There we go. So this is composition in play, right? We create structures and then we combine them together to create larger structures. But we can also add methods to these structs. Say we wanted to withdraw money from our account. We will go down here and we will say func and then a pointer to the struct, and then we will say, let's just call this withdraw amount int64, and then let's just return an error. And then we could say if a balance minus amount is less than 0, we would say return errors new insufficient funds. And if not, then we would just say a balance, and then we subtract the amount, and then finally we just return nil. Now we would also need to record the transaction, and we could do so by adding another method to the transaction struct and then update those transactions associated with the account. Hi, Morten here. Sorry to interrupt. I just want to tell you about my course, Master Full Stack Golang, from which this video is a part of. We start completely from scratch and progressively build up to a production-ready block that you will deploy on your own server, and we will cover things like databases, authentication, SEO setup, and much more. So, If you want to learn full stack web development in Go and become a professional web developer, go to mastergolang.com and get started today. Now, back to the video. Now, the method we just added, withdraw, can be used to describe a struct. And what I mean by this, that in Go we have what is known as dog typing. And there's this little quote that says, if it walks like a dog and quacks like a dog, then it must be a dog. So we could define this in an interface. So say we have an interface here called withdrawer interface, and follows a similar pattern to structs. We have the type keyword, then the name, and then the interface keyword. And in here we would say withdraw amount 64 and then error. Now, anything that implements that interface can be thought of as a withdrawer. And this becomes very powerful when we have, say, different accounts that can send, let's say, money. So if we were to go down here, we could have a function that's called send money. That would have an amount argument, and then let's say receiving, and then there's a receiving account, and then finally we would have a sending account that implements withdrawer. There we go. And then let's just return an error. Return nil. So I'm not going to fill out the logic here, but this simply means that this function accepts anything that implements this withdrawer interface right here. This is very powerful, and when you're just learning about interfaces, it can be very tempting to use them all the time. But as a rule of thumb, these interfaces should be discovered, not created. So once you start seeing the same type of behavior being used across different structs, it can be beneficial to abstract those into an interface. Go comes with a comprehensive standard library, which we will also touch upon soon. But if you want a good example of how we can utilize interfaces to accept more generic behavior, you could look up the IO Writer interface, which does a really good job at describing a simple interface that is then reused throughout the standard library to do the same operation, but in different ways.